Hello guys, and welcome to our after school coding live stream. My name is Ryan Hunter. I'm one of the founders of TechWise Academy, and today we're going to talk about Scratch programming. Now, first question that we usually use to get started, how many of you have actually done coding before or had any coding classes at school or anything like that? Does anyone have any experience coding? And if not, that's okay. That's what we're here for today. We're here trying to learn some things together and talk about what coding is. And so, all right, we have some that have experienced some coding. But so what coding is essentially we are giving instructions to something on the computer. So we're telling something what to do. We're either telling a computer what to do. In robotics programming, we're telling a robot what to do. And we're giving step-by-step instructions that are going to follow along, that the character is going to follow along with. And so today we're going to use the Scratch programming environment. So if you have a tablet next to you or a laptop that you can pull up with a browser, I recommend going ahead and grabbing that now. And we're going to be doing these live streams every Thursday afternoon at 3 p.m., same time and place. And we're just going to cover different topics, talk about coding, and maybe dive deeper into something that you haven't thought of before. So grab those devices and open up your favorite browser window. I have Google Chrome on mine. And in the address bar, type scratch.mit.edu. So Scratch is a programming language that was developed by MIT specifically for teaching younger people how to code or teaching beginners how to code. And so instead of the syntax that we have with a lot of programming languages, the syntax meaning these are the words that we're going to type so that the computer understands it, Scratch kind of takes all of that away and lets us use something called block programming. So we're going to drag blocks of instructions over into our workspace, and those are going to execute the functions instead of typing everything out. It's a great place to start for new programmers, and it really lets us get a feel for the thought behind programming instead of worrying about the syntax. So today we're going to create something new in Scratch. We click this Create button at the top. And this is our Scratch programming environment. All right, so we talked about coding is giving instructions to something, making sure that our characters have these instructions and they're going to do exactly what we tell them to do every time. So, I'm a father as well, and you may see my kids actually coming in and out of these live streams as we do those. So apologize for that. They're at home with me as well, and I know many of you are too. Hopefully they have their shirts on, my sons, when they come through here, but you may see them as well. But when we're coding, we are just giving instructions, and everything that we tell that character to do, they're going to do that. So if our character isn't behaving the way that we think that they should, then it has something to do with our code, and that's what we're going to fix. Today, we're going to talk all about movement in Scratch, though. We're going to talk about 3 different types of movement. We're going to talk about user-controlled movement. So if the player who's playing your game wants to move the character around the screen, how does that happen? Second, we're going to talk about movement by NPCs or non-playable characters. So if you've played video games in the past, you know an NPC is just a character moving around on the screen in the background, and we're going to create a character that does that as well. And then thirdly, we're going to do sort of a hybrid between the two where our user will initiate the movement. So they're going to start something, and then that item is going to move around the screen. So think of this as like Angry Birds. When you pull the bird back and launch it, as the user, the bird goes ahead and launches across the screen, and you don't really have any control over it after you've made the initial launch. So that's what we're going to do today, is talk about those 3 different types of movements within the Scratch programming environment. So first things first, this is our character in our game that we're going to move today. First off, user-initiated movement. How do we let the person playing our game move the character around on the screen? Notice the theme of Scratch is this cat. Cat's name is Scratch. And we're going to make this character move on the screen while we're from the user's perspective. When we're programming with games especially, it's it's called event-based programming. So that means that something has to happen in order for that code to take place. So any of you out there, if you've played video games in the past, what types of things do you do as a player in order to make the character move on the screen? So say you're playing your Xbox or you're playing PC. What do you do in order to make the character move on the screen? Anyone, if you want to type comments, we're on Facebook and YouTube, so comments there either way will come into the screen. But typically, as a player of a game, we have a controller or we have the keyboard that we are using in order to control our character in the game. So that's what we're going to do with our Scratch Cat today. We're going to control the Scratch Cat with the arrow keys on our keyboard. That's really easy in Scratch. What we have to do first is go over to the Events tab on the left. Yeah, we could use the joysticks, correct. So that's one way that we can make our character move throughout the screen, is to use the joysticks on the game. Today we're going to use those up and down arrows on our keyboard. Again, these are the events. These are the ways that we kick off different ways to code in Scratch. And the second one down on the list says when space key is pressed. So I want you to take your mouse or your finger if you're on a tablet and drag it over to this middle area that's our workspace. And I'm going to zoom in a little bit so that you can see my code a lot clearer. When space key is pressed. And notice there's this little down arrow just to the right of space. You can click on that and actually change this to a different button on your keyboard. So I'm going to change this first one to the up arrow, when up arrow key is pressed. So when the up arrow key is pressed, I'm going to make my character, I want my Scratch Cat to actually move up on the screen. And so whenever we are instructing our cat to move, all of those blocks live in the Motion tab over on the left-hand side. And we have the very top one that says move 10 steps. Now I'm going to drag this over real quick, and just to give you an idea of what happens, this code says when the up arrow key is pressed, move 10 steps. So let's see what happens if I do that. I'm going to press the up arrow. What's happening with my cat? My cat is actually moving, but they're moving in the wrong direction. So whenever we are making our character move, we're telling them how far to move each time, but we also need to tell them which direction that they're moving when this arrow key is pressed. So we're going to move 10 steps, but we're going to drag this down a moment, and we are going to tell our cat which direction to move in. And that is with the point in direction block over on the left. So we drag it right up under the arrow key when arrow key is pressed, point in direction, and if you click in this 90, it opens up this little wheel, the little protractor looking wheel that allows you to choose the direction that you want your character to move in. So I'm going to make my character look up and then move 10 steps. So when I do this, now I can make my character move up by pressing the up arrow key. Now you've probably noticed that your character flipped around, and we'll change that in just a moment, but just notice that we told the character which direction to point, and they are moving in that direction. All right, so I'm going to back this out just a moment, and we're going to fix him rotating like it did in this particular section. Just above your sprites on the bottom, and that's what Scratch calls any object that we're giving code to, is a sprite. There's something called direction. We can click on this, and it has that same protractor wheel above. So I'm going to turn him around so that the character's facing the way they should have initially. And then I'm going to click this little arrow key, and I'm going to make sure that you can see this a little bit better. Just underneath of that, they're gray right now, and it looks like two arrows pointing at each other. This restricts how our cat can move throughout the game. So for right now, I want my character to just be able to move left and right throughout the game and not spin around like this first one. That's the default. So make sure that we change this, and that'll keep your character from flipping up when you press the arrow key now. All right, so I'm going to encourage you to go ahead, and I'm going to work through the down arrow next, and I want you to try it as well. I'm going to be doing it on the screen, so if you want to follow along and do exactly what I'm doing, that's fine. But I'd really like you to try it on your own to see if we can get this down arrow working just the way that we did the up arrow. Okay, so I'm going to talk through mine. If you want to mute me and try it yourself, you're welcome to do so. But we go over back to events when space key is pressed and change it to down arrow. And then what two things do we need to do in order to make our character move how we want them to move with the down arrow? All right, we're going to tell them which direction and how much. Nice job. Some people are already knocking that out. We want to go to motion, point in direction, and 180, and then move 10 steps. And now if you press the down arrow with your keyboard, your character will move down on the screen. All right, notice that our character is moving fairly smoothly around the screen. If you want them to move faster, the way that we would do that is change this 10 to a larger number. So maybe 20 steps on both the up and down. And our character will move faster as I'm holding the up and down arrows. But I'm going to change mine back to 10 just for default purposes. That makes it work well. But that's how you make your character move a lot faster in the game, because I know some of you like to go ahead and make them move as fast as they possibly can. And that's the way you do that. You just change the number of steps each movement. All right, so let's go ahead and program the left and right arrows as well. Events, when left arrow key is pressed. Motion, which direction? To the left. And how many? Events, when right arrow key is pressed. Motion, which direction? And by default, this is already correct, 90, and move 10 steps. Now, once we have all of those in place, I'm going to zoom in on mine just so that you can see that, see everything a little bit clearer. Your character should be able to move around on the screen. Just like this. Right, so do we have any questions on... All right, so Shannon, a question on how do you get it to go smoothly? So that's you're very observant there on noticing that our character isn't as smooth. They're kind of jumping forward 10 steps each time that you press the arrow. If you hold down the arrow, it seems to go a lot smoother, but each movement is 10 steps. So if you want it to be a lot smoother, but it's going to be slower, you change this number to a smaller number. So instead of moving 10 steps, I would move 1 step each time. And this is as slow as it will go. And my character seems to move a lot smoother across the screen, but they're not quite as fast. And this is the same consideration that gamers would do for if they're creating something for Xbox or something else as well. Do we make them move super slow so they look super smooth, or where do we find that balance of moving quickly across the screen versus making it look very good? And so that's a trade-off there. You might be able to find a better balance around 6 or 7, but play around with that and try that on your own and see what number looks the best for you. I just recommend everyone being the same number, just so that up doesn't move faster than down, and things like that. But yeah, thank you so much for the question. So we've made our character move, and this is that This is that user-controlled movement that we're talking about. I'm going to show you a trick real quick just to make this a little bit more exciting for you, because right now my cat looks like it's gliding around on the screen. It's kind of floating. Some characters inside of Scratch have multiple costumes. So a costume is different looks for this character. And you can find those by this little tab up in the top middle, just to the right of code. And the cat has 2 costumes. So if I keep switching between these costumes really quickly, it almost looks like my cat is running along on the screen. Not every sprite has multiple costumes, but the cat does. So we're going to change that each time that we move so that it looks like our cat's legs are moving back and forth. It'll almost look a little bit like the Roadrunner in the old cartoon, just because our cat's legs are moving and they're not really hitting a ground or anything. But it does actually add some a little bit more dynamic play to your game. So let's go back to code at the top. And we access the costumes through the look blocks on the left. So on the looks block, it allows us to say something if we want our character to speak during the play, and they don't actually say it out. It just kind of types out on the screen. But down in the middle section, there's something that says costumes. And I want you to grab the next, where it says next costume, and put it at the bottom of every stack of code that we have. And now use your arrows to move around on the screen. And now it makes our cat's legs look like they are going along the whole time. This might be distracting. You may not like that. And that's fine if you don't like it. Just drag those code blocks off and get rid of that. But sometimes I think it adds a little bit to the games as well to have something like that in the background. All right, so any questions on user-based movements? We've got user-based movements. We're going to jump into NPCs in the game, how something would move automatically in the game, but I just want to answer any questions on user-based movements before we jump on. Okay, so we're going to jump into the next type of movement within video games and programming, and that is non-playable characters, or characters that are moving around in the background of our screen the whole time, and the users aren't controlling their movement in the game. So we're going to add a new sprite in order to accomplish that. The way we add a new sprite in Scratch is to click on this small blue cat icon just to the right of the current cat. If we choose on that, then it lets us choose another character to add to our Scratch project. So I'm going to add, there's some dogs here. I'm going to add a dog to put out there with my cat. Just go ahead and click on the dog and they will show up. Notice that all of our code disappeared. And don't worry about this. Remember, coding is just giving instructions to a character or to an object in code. If we click on the cat down here, all of that code is still there. So those are the instructions. That's the code for the cat. Our dog currently has no instructions telling it what to do. So we want to make sure that we give some instructions to our dog so that our dog will do the same thing and continue to move around the screen. I am going to make this character glide around the screen. So in movements within Scratch, if we check the motion blocks at the top, I could make the dog, I could make it move 10 steps, turn a direction, move 10 steps, or move a random number of steps. But really the glide functionality in Scratch already takes care of that for you. It's called glide 1 second to a random position. And I'm going to drag it over to the workspace. And notice this blue block and any of the blocks that don't have a rounded top means that we haven't started this code block yet. We're trying to figure, when do we want this code block to be run on this dog? What thing would happen to make this code, make the dog do this code? Now, Scratch makes it easy to just double click on this and to test it one time. and we see our dog moving around the screen every time that we click it. But we want this to keep happening in our game. So we're going to put this inside of what's called a loop in code. And so whenever something happens over and over again in code, computers are great at allowing you to repeat the same thing over and over again. It doesn't really care. It doesn't need to go to the bathroom. It doesn't need drinks like we do. You know, the computer will do the same thing over and over again. And the way that we do that is over in control. There is a forever loop. That's what we're going to use today. So drag this forever loop out here, and then drag this blue glide inside of that forever. And then we want to tell all of this when to start. All right. So whenever we're asking ourselves, when should this happen? What thing is going to make this code start running? We always look over in the event. So think of an event as something happening in the background, or something happening from the user that makes some code start running. And in this case, we're going to drag this when flag is clicked over. So when flag is clicked is just the default way in Scratch to start a game by clicking this green flag above it. And so think of this green flag as the starting flag for our game. Notice our cat didn't have anything there because our cat's not really doing anything until the user interacts with them. So that's the type of motion for our cat. But for our dog, we want that dog to continue to move the entire time that we're playing this game. So I'm going to click the green flag at the top, and this dog is going to continue to move around the screen. Just like that. So notice it's moving faster and slower as it goes to each random position. And that's because we're telling our dog to go to a random position on the screen. And if the random position was up in this top corner, if it took us 1 second to make it to that top corner, our dog would have to move a lot faster to make it up there than it would to make it if that random position was just over here. And so the 1 second is sort of a speed, and it makes the dog move around on the screen just like this the whole time that we're playing. Yes, and you can also add a next costume in the forever loop. The dog actually has a costume as well. So good catch on that. I'm glad that you're jumping in and trying some things on your own. That's how we learn new things, is just trying it out. And coding gives us a great way to try that and get rid of it if it doesn't work. Maybe I didn't have mine right. Is there a next costume? And yeah. Stop it and run it again. It's gliding. And the dog changes its costume as it's moving around. Now, if we wanted to, every time it gets to a new position, it just changes its costume to a new one. We could also make this happen a lot faster over the entire game, and I'll show you quickly how to do that just because I think it's fun sometimes to try new things. I'm going to drag another when flag is clicked, put it out here, and then put another forever with the next just the next costume inside of it. All right, and so now our dog is moving around like this the whole time. Both of these forever loops are running simultaneously, and so our dog is continuing to switch costumes the whole time that it's moving around on the screen. Maybe that's a little over the top, but we can, in the control statements, add a wait after it, and that lets it changes it. It doesn't have to wait till it gets to every random position, but it also changes it a little bit faster. A little bit faster than inside of this forever loop, and a little bit slower than just by itself inside of this forever loop. So that's a few ways to do that. I think it's always fun to try new things out and make the characters move on the screen as well. All right, so any questions on non-playable characters, how to make them move around the screen? The glide is your best bet for making characters move around smoothly across the screen. Okay. And so lastly, we are going to jump into user-initiated, and then it's sort of a handoff at this point. So usually we see this in projectiles in gaming. So, or we're launching a ball across the screen. Our character is going to do something to make that launch take place, but we going to do something to make that launch take place, but then they're totally hands off at that point. So it's going to continue across the screen in the direction that it was going. Yes, we are going to do we can add a backdrop at the end. Let me get through this movement here, this last little bit of movement, and then I'll show you how to add backdrops within your Scratch environment just to make the game have a little bit more character. I agree, the white background is probably just not exciting enough for our game. So we're going to have something launch across the screen, and we're going to have it launch from the cat. So maybe the cat's throwing a ball. That's what we want to have created in this particular case. We're going to have the cat throw a ball, and then let's make it throw the ball at the dog and see if we can do that while the dog's moving around on the screen. So I'm going to show you how to do that. Let's add a new sprite. So choose a sprite. And I'm going to grab this, just the plain ball that's over here. And that's out on the screen. Notice that there's no code for the ball, and so it's not really doing anything at this point. We're just going to make it, whenever our cat launches it, it's going to go across the screen and see if it can throw at the dog while it's moving around. First things first, when the flag is clicked for this ball, I want the ball to hide. All right, I'm going to get rid of it and make sure so the dog doesn't really know what the cat's up to in our particular game. We go to looks, and in looks, down at the bottom, there's these small blocks, show and hide. I'm going to drag over hide. So when flag is clicked, that means when I click this flag, the ball should hide, right? It's gone. It's not showing up on our screen. The dog is none the wiser at our cat's plans for the future. And we're going to make that ball show up and launch towards the dog when something happens, from the user. So think back to what we talked about earlier. Whenever we hear the word when something happens, where are we going to go to the code blocks? What section of code blocks are we going to go to over on the left? And that's okay if we're not. It's over in the event. So if you're thinking to yourself when something is going to happen, or when does this happen in our game, really we want to start that off over in the events. So so the motion is what's going to make the ball move, but we have to think about when that starts off. And that's where we start off with events. So events, drag over a when space key is pressed. So I like the space key whenever we're launching lasers across the screen or balls across the screen. That lets the user have something easy on their keyboard to make that ball launch. So when space key is pressed, I want the ball to motion. I want the ball to go to not random position, but to sprite 1, which is our cat. So we change this go to in motion to sprite 1. When the space key is pressed, ball, wherever you are, go to sprite 1. And the reason we're doing that is because I could be moving my cat around on the screen, and I want to make sure that the ball is launched from the cat every time, no matter where my cat is on the screen. Once we're there, I'm going to go back to looks, and I want to show the ball. Because remember, we hit it up here when the flag was clicked at the beginning of the game. When the space key is pressed, go to sprite 1 and show. So I'm going to test this out. Whenever we're creating code, we definitely want to try it as much as we can as we're going along. That helps us discover errors in our code. So if I press the space key, the ball went to the cat. All right, so if you move your cat around with your keyboard and press the spacebar key, you should see this happening with your cat. All right, so I want the ball to show up at the cat and then launch towards the dog. And so the way that I'm going to do that is remember, whenever we have something moving across the screen, we need to know the direction that it's going to go to start out. And so the direction it's going to go is wherever the dog is when we launch it. So the dog could be moving around and could be anywhere on the screen. I want to make sure that we are shooting the ball directly towards the dog as it goes along. And the way that we do that, if you're in the code for the ball, I'm sorry, it keeps flipping back and forth. I'm choosing the sprites. We want to point towards dog 2. And this is in the motion blocks, point towards dog 2. And then we are going to go to the control blocks. And I'm going to go down a little bit, and I'm going to do this repeat until loop. So repeat until means that we are going to run whatever code's inside of this until this thing inside that we're going to set up in just a moment happens. So what we're going to repeat is that we are going to go to motion and move 10 steps. We want the ball to move 10 steps until it either touches the edge or it touches the dog. That's what we're going to have set up in this case. And I'll zoom in a little bit more just so that you guys can see my code. Make sure that yours matches mine. So when the space key is pressed, go to sprite 1, show up, point towards the dog, and repeat until move 10 steps. And that until we have two different things that could happen. We either want to go, yes, we end up going to the sensing to be able to detect if we've touched the dog. So good. We've got some people that have used Scratch before, but first I'm going to go to the operators and bring out the one that says or right down in the middle and drag it inside. Notice it's the same shape as this grayed out area on the repeat until. I'm going to repeat until we're touching the edge or we're touching the dog. And we do that as you've talked about in the sensing. And that's the very top block that says touching. So it's touching and it has a question mark. It means, am I touching this thing? Is this thing true or not? Am I touching the edge? Or am I touching dog 2? And put that on either side. So that way we have two conditions in here. And that's what these are called encoding, that we have a condition. Is this true? Or is this thing true? And if either one of those are true, we are not going to move forward anymore with our ball. And so what I'm going to do is right after this repeat until, I'm going to hide the ball again, just so that we can make it look like the ball disappeared. So I'll go to hide in the looks blocks, go to hide and put that underneath of your repeat until. And now we should be able to press the space key. Let me start the entire game over. Make sure it's stopped by pressing the stop sign. Press the green flag. The ball's move, or the dog's moving around. The cat's sneaking by and throwing balls at the dog as we go along. So we've made a simple little dodgeball game, which is probably not fair to the dog because we are detecting where the dog is every time, right? So the dog doesn't really have a chance against this. The sniping cat made it past that time. There you go. That's how you create a simple movement. The third of our movements, which is it's initiated by the user, but then it happens without us at the end. And you can add a score, you can add sound effects and lots of different things with your game once you're done with that. But today, just focus on the movements. It was requested that we add this backdrop down here in the for our background, and let me make sure that you can see that well. The way that we add a backdrop is just in the bottom right where it shows, it looks like some mountains in the background. Choose one of those. And where do you want this game to happen? I'm going to make this happen. Choose your own for this one. You can choose whichever thing you'd like, but I'm going to choose maybe the woods down at the bottom. All right, so do we have any questions about this? Is anyone having any issues that I can help solve while I'm here? If we want to, we can add a score. If there's no other question, then everybody has this perfect. We can add a score. But just want to see if there's anything that I can answer before we move on. No one? All right, that's fine. I'm glad that it worked out well and everyone has this launching. Just a note, the ball itself has a costume. So if you switch the costumes of the ball, you'll actually change the color of it as it goes along as well. And so if you want to change the color of the ball that launches out, just like we did earlier with the costume, switch that to a new costume. All right, so let's go ahead and add a score real quick because that was a request, and it's pretty simple to add a scoring mechanism to our games. Just a second. So the ball won't show up for me. All right, so definitely make sure that we have this show. Let's see if I can zoom in a little bit more. Right under the when space bar is pressed. So when space key is pressed, go to Sprite 1 and show. Do you have that show block in place that makes it show up? No, maybe. Definitely make sure that that's in place because that's what this block technically does. It makes it hide and then come back into play when we're ready for it to show up. It's a great way if you are, say you're creating a game and you don't want all the characters to show up at the beginning, but you want them to come in later. You can hide them when that green flag is clicked and then come back in later and make them show up at a certain point of the game. So you do have the show on the ball. Definitely make sure that, because here's the other thing that could happen and what possibly could be happening in your situation. It's pointing towards the dog. It's repeating until touching edge or touching the dog. If either of those are not happening, then it will move 10 steps. But if we're touching the dog or we're already touching the edge, then it will not move 10 steps and it will just jump ahead to this hide at the bottom. So that might be what's happening if yours is not showing up right away. Try getting rid of this hide at the bottom for a moment just to check out if the ball shows up. What will happen is it's just going to stay wherever it either touched the dog or touched the edge for the time being. And that's a good way to troubleshoot it, is just remove that last piece, that last code block, to make sure that that it's not jumping past this loop directly to the hide, because that might be what's going on if that's happening. Oh, had it on mouse pointer. Okay. And said it had it on mouse pointing. So if the ball was touching the mouse pointer, then it would not move 10 steps and it would go directly to the hide. So good catch. Nice job debugging on that one. I'll drag my hide back into play. Okay, so we're going to quickly add a scoring mechanism, and then we'll probably be wrapping up today's live stream. But whenever we are keeping track of something happening in a game, and that number can change over time, we do what's called a variable in the code. And that variable, just think of it as a bucket to hold this number, and we can change that over time. If you get into more advanced math, you end up putting like letters in for numbers that you're unsure about, and those are called X's. Those, maybe an X or a Y, those are variables as well. And so same concept with code. We're just using that variable as a placeholder that can change over time. The way that we add a variable, you may have guessed, is over in the variables block on the left, and make a variable, the very top icon. And we give the variable a name. And in this case, we're going to keep a score. I'm going to say score. And we want this available to all sprites. Cloud variable, if you see this, this is if you want to keep a running high score of your game. Say you publish your Scratch game and you want to keep track of the all-time high score across everybody who's ever going to play it on your link. You could store this as a cloud variable and just update it there. But for our game that we're doing today, just create a for all sprites, click OK. And notice that right up, way up at the top, a score showed up. A score variable showed up and has the number 0. You can right click this with your mouse and change what this looks like. Normal readout, large readout, or a slider. Maybe you're wanting to adjust some settings in the game. That's what you would use for that type of variable. But I'm going to leave it on normal readout. And I'm going to make this score go up. When should that score go up? When do we think we're going to get a point in our game? Anyone? What would be a good time to give us a score? So I'm going to do that when this ball touches the dog. So we've hit the dog with the ball. Probably not happy about it, but we're going to get some score, and that's how we score in our game. I want to make sure that I'm on the ball. Make sure that that sprite is selected, because all this code that we're going to have to change the score is going to live here. All right. When the ball touches the dog. Yes, that's exactly when we're going to do it. Sorry, I realized just as I was moving ahead that it may take just a moment to type that out. So, but thank you for putting that. When the ball touches the dog, that's when we want to give ourselves some score in this game. So I'm going to go when space key is pressed, look at my code, go to sprite 1, show, point towards dog 2, repeat until, move 10 steps, and then hide. So I'm going to go right after this, right after the loop, but right before the hide. And in the control blocks, I'm going to bring an if-then statement inside of this. Right underneath of the repeat. And stack up my hide right underneath of that. So just above this, we're going to repeat until we're either touching the edge or touching the dog. We're going to keep moving until one of these things is not true. But we only want to give our characters points if they're touching the dog. Maybe if they miss the dog completely and it touches the edge, we get minus points. How about we do that in our game? So we're going to bring another or. What? I'm going to back this out a little bit. We can do this several ways, but I'll continue with what we're doing here. That's fine. We're going to go back to sensing. If touching edge, then in my variables, I'm going to say change and switch my variable to score by -1. So if we've dropped out of this loop, that means we're either touching the edge or we're touching the dog. If we're touching the edge, then change score by -1. That means we lose a point. You missed the dog. I'm going to bring another if statement in control. If then. Put it underneath of the first one and above the hide. And for this one, I'm going to say touching dog 2. And if I'm touching dog 2, then I'm going to go to variables and change my score by 1. I get a point. So I get 1 point added to my current score if I've touched the dog with the ball. All right, so I keep getting points. I'm going to see if I can. Missed 1, and I'm back to 4. Okay. And that is a great point. We could have done an if, then, or with an else inside of that. That's another control block. It's right here. We can do that. I started out going in one direction, and I kind of shifted it. And so you could. And the great thing about code is that we can, there are multiple ways to solve the same problem in code. And so your creativity as a programmer can really come out when you're creating things like this, because you may do something a totally different way than I did. And that's okay. We're doing the same thing and we're accomplishing the same goal when we're setting this up. So there's lots of ways to do this. I appreciate the feedback with that, so that we can make sure that we do that this way. The other thing is, real quick, before we jump off on today, is we want to make sure the score resets every time, because when we start a new game, my score is still left over from before. So when do I want the score to go back to 0? I want it to go back to 0 when we click the flag. So when flag is clicked, variables, I want to set score to 0. So this is the very beginning of the game. We're resetting our score for it, and that's how we would set that up. Start it over at 0. Now I can get points by hitting the dog. If I'm not in my Chrome browser and hitting a different key with the ball, I can score lots of points. All right, so I'm going to stop that up. Any questions that you guys have about this that would, about movement in the game? Anything that you guys have? And one of the things that we're going to start doing, we're going to do this every Thursday. Like I said, please join us. We just want to explore coding, try things out, learn something from each other. I would love to learn what you're working on and be able to showcase that in some of these videos. So if you're working on something great with Scratch and you want to share that with me, you can post a link to your Scratch project into one of these feeds, and I may showcase it next time on our video and just walk through your code and allow you to check that out. But thank you guys so much for joining us today. We're so excited that you found coding and that you're enjoying the process of doing that, and appreciate it if you would join back with us, tell your friends about us, and we'll be here next Thursday at 3. Thanks.